Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about how to find parallel vectors. In the previous video, I just gave you the properties of a parallel vector, talked about having no angle, the angles are zero, and also introduced the concept. So now we're going to solve some questions to see if we can determine if two vectors are in parallel and either in the same direction or in the opposite direction. And before I proceed, don't forget to like, share, and subscribe. If you've not clicked the notification bell, I don't know what you're waiting for. Please do so that when I post new videos, you'll be the first person to know. All right, so let's go. So the first thing is that two vectors, like we said in the previous video, when we have two vectors A and B, they are said to be parallel if one of the vector is a scalar multiple of the other. So that means you have things like A is equal to KB, okay? So if we have two vector A and vector B, they are parallel if they have a multiple here, K. So, but another thing you need to know, if K is greater than 0, it means that A and B are in the same direction. If K is less than 0, it means that A and B are in the what? Opposite direction. Are you seeing it? And if K is equal to 0, it means that it is a zero what? Vector. All right? So that is that. So what we need to do, I'm going to write it down because I'm aware that students do take notes. I'm going to write what I just said and explain down so that you can go back to your notes and we'll pick some examples for this, okay? So let's go. All right, so let's start. So we said if two vectors A and B. So we have two vectors, A and B, are said to be parallel. Okay. So vectors A and B are said to be parallel vectors. Okay. So you can say they are said to be parallel vectors if one is a scalar multiple of the other. Okay. So if one is a scalar multiple of the other. So what I'm saying is that, so if you have vector A and B, okay, so that means A is going to be equal to, there's a K here, KB. So now this K is what is makes it parallel or not. So where K, okay, where this K is a what? Scalar quantity. Or let's just say where K is scalar. Let's just say where K is scalar. All right. So to make it easier, I can say real number. So if you have two vectors and they are parallel, so it means that K is scalar and also that they are real. Okay. So the next one is, when we now know the value of K, so we can now analyze this K we have here. So how do we analyze it? So if K is positive, if K is negative, if K is 0, it can tell us what type of parallel vector is that. So for instance, if K is positive, it means that it's in the same direction. A and B is in the same direction. If K is negative, it means that it's in opposite direction. If K is equal to 0, it means it's a 0 vector. So that means hence K, okay, can be positive, negative, or 0. Okay? So you can have different ones. So for instance, if K is positive, what we mean k is positive, so it means that k is greater than 0. Okay, so when you solve and your k is positive, it means that A and B are parallel in the same direction. So when you solve and you have your k is positive, so that means A and B are parallel in the same direction. So that means what I'm saying is that if you have A is equal to KB, okay, and your k is positive and k is greater than 0, so it means that A is in this and B is also here. So A and B are parallel in the same direction. Now, but if you solve it, and in this case, you had k to be negative, all right? So in this time, you had k to be negative. So that means you had k to be less than 0, okay? You had k to be less than 0. So that means what happens now, unlike the first one, A and B are parallel, but in the opposite direction. Okay? Are parallel, but have opposite direction. So for instance, when we have A is equal to negative minus KB. So you can see, you still have the K, but the K is negative here. So that means the K is less than 0. It means that you have A in that direction, but the only thing is that B is going to be in the opposite direction, but they are still parallel. Okay? Now, but if you now have k to be equal to 0, it's what we call a zero vector. So if k is 0, so that means A is a zero vector. And that is that for that. So so what we are finding, if two vectors are parallel, what we need to find is that we need to find k, and k has to be equal for both of them. Okay, so k has to be equal for both of them. Good, and that is how you know that two vectors are parallel. So we can then rewrite this. So we can then say from this now, we know that A is equal to KB, or we can say K is equal to A over B. So basically what we did, let me just show you my thought pattern here. So A is equal to K over B, right? KB, divide both sides by B. So this is going to cancel that. So therefore, we can now say K is equal to A over B. So if they are parallel, you can have it this way. Or if you want to, you can have it this way. And that is it. So if you can get the value for K, and you see that the K is the same for both A and B, so then you can now say the two vectors are parallel. All right, so let me pick a quick example and just to explain to you, all right? So let me just pick a quick example here. So for instance, if we have vector A, so if we have something like vector A, okay, and vector 5A, these are parallel. And in the same words, and in the same direction. Okay, so if you have vector A, vector 5A, because you can see the K here is 5. So because here, the K is equal to 5, and 5 is greater than what? 0. So that means it's positive, and therefore it's parallel in the same direction. Also, if you have something like vector B and another vector, you have -1/3b, same thing, they are also parallel. But in what? In different or in opposite direction. Or you can say exactly opposite direction. Okay? So that means here, k is equal to -1/3, and -1/3 is less than 0. So hence it's going to be in the opposite direction. All right. Let's go into something more interesting now. Let's go into something more interesting. Now let's solve, let me call this extra questions. So let's solve exercises. So let's pick some exercises that are more interesting that we have to determine, all right? So number one, all right? So we had this question here. We're told that given that vector P and Q are not parallel. So that means we have these two vectors, vector P and Q, but vector P and Q are not parallel. So that means they are not parallel. Okay? So we have vector P and Q. So this P and Q we have here, these two vectors are not parallel. Now, the question now is they want you to now state whether or not each of the following pairs of vector are parallel. Okay? So the first one we have 2p and 3p. Okay? So that's the first thing we have. 2p and 3p. So remember I told you if two vectors are parallel, so just a quick reminder, I told you if two vectors are parallel, it's going to be in the form of A is equal to what? KB. So if, for instance, vector A and B are parallel, you have to have a K, there will be a scalar quantity between both of them. So let us check. Would there be a scalar quantity between these two? So we're going to have 2p is going to be equal to K, the scalar quantity, 3p. Are you seeing it? So we're going to look for K now. So we're going to look for K. So we now divide both sides by what? 3p. Are you seeing it? So this will cancel that. So that means K is going to be equal to 2p over, okay? You're going to give you 2p over 3p. So then this will cancel this. So therefore, K is going to be equal to what? 2 over what? 3. Are you seeing it? So now the K is 2 over 3. And you can see because it's 2 over 3, it means it's what? Parallel. But you don't just stop there. 2 over 3 means that it's also K is greater than 0. So it's going to be parallel in the what? Same direction. So you can see, although P and Q are not parallel, but 2P and 3P are what? Parallel in the same direction. All right, let me pick another example for this so that we can understand this better. So let's pick another example. So we have number 2. You are told now to check if, for instance, P plus 2Q and 2P minus 4Q are parallel. So now, are these two parallel? So to check if they are parallel. So now, so that means for this to be parallel, so it means that P plus 2Q, remember I said for two things to be parallel, A must be equal to what? KB, all right? So the first vector must be equal to a scalar quantity of the second vector. All right, so this must be equal to a scalar quantity K 2P minus what? 4Q. All right, so then what do? We're going to open the bracket. So we're going to have P plus 2Q is equal to 2PK, or let's say 2KP, 2PK, or anyone, 2PK minus 4QK. So that means for these two vectors to be parallel, P must be equal to 2KP, and the other one, 2Q, must be equal to 4KQ. Are you seeing it? For this to be parallel, 2Q must be equal to minus 4QK. And therefore, the K in both of them must be the same. And the K in both of them must be the same. The K in both of them must be the same to be parallel, okay? So for this to be parallel, it means that this and this, the K in P equals to 2PK must be the same K in 2Q minus 4QK. And the K must be the same in both to be parallel. So just a quick reminder, remember in algebra, we talked about something similar to this. So we just keep going now. So we're going to solve the one on the right. So we're going to have P is equal to 2PK. Okay. So to find K, we divide both sides by what? 2P. So this will cancel that. So therefore, K must be equal to P over 2P. And this is going to be P will cancel this. We'll give you 1 over 2. So that therefore, in this part here, K is equal to what? 1 over 2. Now let us see if we're going to have the same K in the next one. So we have 2Q is equal to minus 4QK. Divide both sides by minus 4Q. This will cancel this. So therefore, we now have the K to be equal to 2Q divided by minus 4Q. And this is going to be the Q, we cancel that. So it's going to be 2 divided by minus 4. And this is going to give us minus 1 over 2. So therefore, the K here is going to be equal to minus 1 over 2. So as you can see, we had the K for P was half, while the K for the other Q was minus half. So therefore, we can now say, in this case here, therefore, they are not parallel. Since we have 1 over 2 is not the same thing as minus 1 over what? 2. So it means that is what? These two lines are not what? Parallel. Okay? So the two lines are not parallel. Okay? Now let's pick another one. So C, we have is 3P minus Q, and P minus 1 over 3Q. Are these parallel? So we'll do the same thing. So if two vectors are parallel, A must be equal to what? KB. A must be equal to KB. So let's go. So we're going to have 3P minus Q must be equal to K, P minus 1 over 3Q. Are you seeing it? We open the brackets. So we have 3P minus Q will be equal to KP minus 1 over 3 KP. Sorry, KQ. All right. Now, similarly, like I said, if this has to be parallel, okay, it means that 3P must be equal to what? KP. Okay. And also, the other one, the minus Q, must be equal to minus 1 over 3 what? Minus 1 over 3 KQ. So minus Q must be equal to minus 1 over 3 KQ. And if they are parallel, the K in the first one must be equal to the K in the second one. Okay, so if they are parallel, the both K's must be the same. Okay, because the constant has to be the same for both A and B, right? So if they are parallel, the K in both scenarios must be the same. Okay, the K in both cases must be the same. Okay, so let's go. So let's start with the first one. So we have the red one. What was the red one? We have it to be 3P equals to K. So let's go with that one first. I'll change this to red. So we have 3P. We have 3P is equal to KP. Okay. Then we then divide both sides by P to make K the subject of the formula. So this will cancel that, right? And P will cancel P there. So therefore, in this case, K is equal to what? 3. Now we go to the next one. We have minus Q is equal to minus 1 over 3KQ. Okay, so in order to remove this 3, this fraction, so usually I don't like working with fractions. I usually try to get rid of it. So in order to remove this fraction, I'm going to multiply both sides by what? 3 to make it easy. So it's going to give us minus 3Q will be equal to, so when you have minus 1 over 3 times 3 will give you minus 1. So it's going to give you minus KQ. Is that making sense? Now, in order for us to find K, I'm going to divide both sides by minus Q. I'll divide both sides by minus Q. All right. So we have minus Q. So let's see. So minus Q, minus will cancel this. Q will cancel that. And that will give us K. And that will be equal to minus will cancel minus to become plus. And Q will cancel this. And that will give you what? 3. So you can see here we got 3. While in the other one, we also had what? 3 as well. Okay, so now in this case, we have the K is equal in both P and Q. So therefore, because we know that, change this back. So we know that the 3 we got for K was still the same 3 for P. So the 3 in P was equal to the same thing. So therefore, it is what? Parallel. Now, but in this case, 3 is greater than 0. Because 3 is greater than 0, it's going to be parallel in the same what? Direction. Okay? So 3 is greater than 0. It means that it's going to be parallel in the same direction. All right, so we're going to pick more examples. All right, so let's pick one more or maybe two more. Okay, so we have D, and we have P minus 2Q, and you're seeing if it's parallel with 4Q minus 2P. Okay, so let's see if it's parallel. All right, so let's check this out now. So remember we said for it to be parallel, it means that A must be equal to what? KB, all right? So let's check it out. So we have P minus 2Q must be equal to K 4Q minus what? 2P. We open the bracket, so we're gonna have P minus 2Q will be equal to 4KQ minus 2KP. And like I said, for this to be parallel and equal, so that means this must be equal to, sorry, this is P minus 2Q, and this is 4Q minus 2P, all right? So the P must be equal to minus 2KP. So the P must be equal to minus 2KP, while the minus 2Q must be equal to 4KQ. So minus 2Q must be equal to what? 4KQ. And also, for this to be parallel, K must be equal on both sides. To be parallel. Does that make sense? K must be equal on both sides to be parallel. So let's check this out now. So I'm going to start with the red one, the P. So we have P is equal to minus 2KP. We're looking for K. I'm going to divide both sides by minus 2P and this by minus 2P. Minus 2 we cancel minus 2. P we cancel P to give you K. P we cancel P, and you're going to have minus 1 over what? 2. Are you seeing it? Now for the green one, that is the 2Q. We're gonna, for the Q part, sorry, we minus 2Q will be equal to 4KQ. Are you seeing it? To make K subject of the formula, I'll divide both sides by 4Q, and I'll divide this side by 4 what? Q. 4 we cancel 4, Q we cancel Q, and that will give me K will be equal to, this will cancel that, and minus 2 divided by 4 is going to give us minus 1 over 2. All right, so this is going to be minus 1 over what? 2. So you can see the K in this part is exactly the same thing as the K in that part there. So we can now move on to the next step. So we can say, therefore, because we had minus 1 over 2 on the left-hand side and minus 1 over 2 on the right-hand side, so we can now say the two vectors are what? Parallel. Now, but you will notice that the K we had was minus 1 over 2, and which is less than what? 0. And because it's less than 0, it's going to be parallel in opposite what? Directions. Okay? And that is that for that. Let me just pick one more. Okay, let me just pick one more. I've solved a lot of questions here, so please go to the textbook, practice more questions. That's the best way for you to be very, very, very proficient in these things. So we have this one. We have 3/4 P plus Q and 6P plus 8Q. Okay? So, as usual, if they are both parallel, it means the first vector must be equal to KB of the second vector, right? So then we can now say, you can put it like 6P plus 8Q must be equal to K 3/4 P plus Q. So you can see it does not really matter. You can put it the K with the 3/4 P plus Q, or you can put it with the 6P plus 8Q. Does not really matter. You should get the same thing. All right. So we're going to open the bracket. So it's going to become 6P plus 8Q will be equal to 3/4 KP plus KQ. Are you seeing it? Then for this to be equal, that means we need to know that 6P must be equal to minus 3/4 KP. And also 8Q must be equal to what? KQ. And if they are equal, so that means for it to be parallel, K must be the same in both cases. To be parallel. Okay, so let's do that. So we're going to start with the red one. So we have 6P is equal to 3/4 KP, all right? Now, in order to get rid of this 4, this fraction, I'm going to multiply both sides by 4. You're going to give me 24P is equal to 3KP. Now, I divide both sides by what? Because 3/4 times 4 will give you 3. So that's the reason I multiplied both sides by 4. I'll now divide both sides by 3P. And this will cancel that. P will cancel this. So K will now be equal to, P will cancel P. Then 24 divided by 3 is going to give me what? 8. So the answer we're going to get here is going to be 8. Now we'll go to the next one. This is simple. 8Q is going to be equal to KQ. To make K, we divide both sides by what? Q. Then Q will cancel that. So we're going to have Q cancel that. So we're going to have K is going to be equal to what? 8. So you can see from this point here, we're having 8 in both cases. So we now have 8 is equal to 8. So the K for the first, for P was equal to the K for Q. So that means this is what? Parallel. And because K is greater than 0, it means that it has to be in the what? In same direction. So it's parallel in what? Same direction. So I can keep on going on and going on and going on to solve several questions. It's exactly the same thing. So for it, you need to just know for it to be parallel, it means that you have the scalar quantity, and if it's greater than 0, it's in the same direction. If the K is greater than 0, same direction. Less than 0 is in the opposite direction. Okay, so we're going to go to the next video. We're going to talk about the dot product of parallel vectors. So if you have parallel vectors, how do you find dot products for these ones? Okay, so that's the next thing we're going to talk about. So that's why it's very important for you to subscribe and click the notification bell so that when I post the next video on the dot product of parallel vectors, you'll be the first person to know. All right, so I'll see you soon. And if you have any question, please send me an email and I'll get back to you as soon as I can.